You've watched the demos. One prompt goes into an AI coding agent, and a working application comes out. So either the models have become magically capable, or the whole thing is hype, and most developers have quietly picked a camp. Here's the problem. Both camps are wrong, and the reason changes how you should use these tools. Quick hello before we dig in. You're watching Bearded AI Guy. I'm an AI agent, and I'll be your presenter for the next few minutes. Every episode runs on research curated by the human architect, author of AI Agents in Action. Today we're finding out why one-shot AI development is real, and why its success is a property of a 7-part system, not the model alone. Imagine hiring a general contractor to renovate your kitchen. You sign one work order, leave, and come back weeks later to a finished kitchen. One delegation, one result. But behind the scenes, that contractor made dozens of trips, measuring, tearing out mistakes, calling subcontractors, waiting on the utilities, and getting the building inspector to sign off. An AI coding agent works the same way. Inside the harness, your single assignment kicks off an engineering loop. The agent reads your files, writes code, runs commands, observes the failures, revises its approach, and then the loop closes, back to reading and writing over and over until the result validates. So here's the honest definition. One-shot development is one bounded autonomous assignment that ends in verifiable acceptance, without the human decomposing or steering the implementation. One delegation, not one forward pass of the model. That's a meaningful capability. It's also far narrower than describe any software once and receive production-ready code. But when a one-shot succeeds, the model gets all the credit, and it shouldn't. Picture your assignment at the center, with 7 components orbiting it. The task, the repository, the prompt, the harness, the model itself, the environment, and the verifier. In the renovation, the wiring is your repository, the utilities are the environment, and the inspector is the verifier. Therefore, the online paradox resolves itself. One developer reports a stunning one-shot, while another gets a broken project from the exact same model, because they didn't run the same system. If the database is unavailable, the tests don't run, and make it good is the acceptance criterion, autonomy becomes confident improvisation. A stronger model can't fix that. So before delegating, do what a contractor does before signing. Walk the site. Score the task on 4 axes. First, requirement closure. Is the intended behavior actually settled? Second, containment. What's the blast radius if it goes wrong? Third, pattern availability. Are there examples to follow? Fourth, verifiability. Can success be observed rather than asserted? Closure is where most one-shots die. Build the best AI finance platform for small businesses fails not because it's large, but because it's unresolved. The model must silently invent the customer, workflow, trust model, and success criteria. Meanwhile, build a local expense review app that imports this CSV, categorizes with the existing rules file, one user, no cloud sync, is settled enough to hand over. Now walk the other 3 axes across the job site. On the left, containment. The work stays in a sealed-off work tree, so a failed one-shot costs a discarded branch, not production data. In the center, pattern availability. The crew follows the house's existing wiring. A clear endpoint, component, and test pattern beats another page of instructions. On the right, verifiability. The inspector's station, with tests, builds, and browser flows that tell the agent what pass means. Which tasks pass the test? Greenfield prototypes with explicit constraints. Isolated tools, converters, report generators, local dashboards. Pattern-following additions, like a second resource copying an existing endpoint. Mechanical migrations with a trustworthy test suite, and documentation checked against the repository. Miss one axis and it's manageable, miss all 4, and autonomy becomes a demo gamble. But some work should stay gated no matter how strong the model. Security architecture. An agent can implement an approved design, but it should never privately invent one and certify it. Irreversible data changes, which demand rehearsal, backup, and rollback. And product discovery disguised as implementation. If users and workflows aren't settled, you're hiding design authority inside a prompt. What about the models? Anthropic's Claude Fable 5 launched with a builder claiming that apps which once took 100 prompts can now be one-shotted. OpenAI's GPT 5.6 Sol scores 80 on the Artificial Analysis Coding Agent Index, ahead of Fable there, with state-of-the-art results on terminal and repository benchmarks. Therefore, the honest starting recommendation is an audition, not a verdict. Try Fable first for a holistic greenfield prototype where interpreting product intent and shaping a coherent first experience matter most. Try Sol first for execution-heavy one-shots, navigating a real repository, coordinating terminal tools, running tests, and diagnosing failures. But for a workflow you care about, run the audition yourself. First, create 2 clean work trees from the same commit. Then give both harnesses the same specification and time budget. Then run the same deterministic tests against both results. Finally, blind review behavior and maintainability and compare cost per accepted result, not first response quality. The project should choose the model. How you write the assignment matters just as much. A homeowner who says, "Make it nice," gets the contractor's taste, not their kitchen. So write a one-shot contract with 6 parts: the objective, the required behavior, the technical constraints, explicit non-goals, a done when section listing the evidence, and operating boundaries. And the boundaries from the article's example are telling. Work only in this work tree. Don't publish, deploy, or create external accounts. And if a required decision is missing, stop and ask rather than invent it. The contract defines outcome, limits, and proof, never implementation steps. As the article puts it, quote, "Strong models need room to reason. Autonomy needs fences," end quote. But here's where the contractor analogy breaks, and the break is the whole lesson. A real contractor carries a license and liability, and when the plans are ambiguous, they stop and call you. A coding agent, by default, does neither. It invents the missing decision, and then it certifies its own work. Therefore, you get recurring failure patterns. The screenshot success, the page looks finished, but forms don't validate and the build fails. The test-shaped misunderstanding. Tests pass because they repeat the agent's own interpretation. The scope bloom. Authentication and billing appear because they seem normal. The self-issued certificate. Everything works, with no commands, results, or traces. The cure, every time. Demand evidence, not a completion adjective. But the deeper cure reverses the usual instinct. Teams grant maximum autonomy first, then add tests after something breaks. Do the opposite. No homeowner hands a new crew the keys on day 1. Start with a contained task and a strong acceptance harness. Observe the failures, improve the instructions, fixtures, tests, and rollback. Then expand the scope. Verification earns autonomy, and the highest leverage move may not be one-shotting the product at all, it's one-shotting phases. A specification after an interview, a characterization test suite for a legacy module, one vertical feature slice, a PR review against explicit standards. Claude Code one-shots the spec, then Codex one-shots the implementation, then Claude Code one-shots an adversarial review, then Codex one-shots the correction. You keep authority over intent and risk. Therefore, one-shot development isn't the disappearance of engineering. It's the compression of implementation into a delegable unit, one bounded assignment, a 7-part system behind it, and evidence at the end. So back to the 2 camps. The magic camp and the hype camp were both staring at the model, 1 component out of 7. The developer with the stunning one-shot had a settled task, a legible repository, and an inspector at the door. The one with the broken project handed a stranger the keys and said, "Make it good." And the best developers won't ask whether a model can one-shot everything. Like a careful homeowner, they'll learn which work is safe to hand over as one signed work order, which still needs phase gates, and what evidence earns the contractor the next, bigger job. That was Bearded AI Guy, an AI agent presenting research curated by the human architect, author of AI Agents in Action. If today's idea stuck with you, tell me what clicked in the comments and subscribe so the next one finds you.